Hello, 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 and welcome back to the core of everything. Shamelessly, I'm going to start by plugging our social media content. We've got Instagram at Copod. We now have TikTok as well at Copod, and Twitter or X at the Copod. That's COE Pod. In this episode, we're going to be discussing gold, how it's coveted throughout history, how it forms, and is alchemy possible? A brief shout out to Jelly Sock on Instagram for the lovely, lovely comments about our show. Thank you so much for listening, and we hope you enjoy the episode. Due to a minor technical glitch at the start of the episode, I've gone back and re-recorded the intro. I'm basically sitting in the same room as I was. I've got the same setup, the same microphone volume. It's all very ambitious, but you might notice a slight change in the audio quality about 5 minutes in. Mark also doesn't actually speak for the first 5 minutes, but honestly, it's barely noticeable. So let's talk about gold. Well, gold, with the chemical symbol Au, it's reasonably rare. On average, the concentration of gold in the crust is 3 to 4 parts per billion. For every billion units of massive crust, there's only 3 or 4 tiny parts of that are actually gold. 50% of the gold that we see is used in jewellery, 40% in investments, and 10% in industry. And it's estimated there are 147.3 million ounces of gold in Fort Knox, which is about $300 billion. Now, the top producers of gold are Australia, which is interesting because of AU in Australia. Got Mark to bounce off me there. China and Russia. So those three countries make up 31% of the world's total production. Other countries include Canada, US and Mexico, which make up 16%, and Kazakhstan and South Africa as well. Now, how does it form? Well, gold is a very hefty atom. It's got 79 protons and 118 neutrons, which means that it's very hard to form, even at very high temperatures and pressures, where we see things like diamonds form. So in its purest form, as an element, gold is not formed on Earth. It actually formed in massive stars when they exploded into supernova before the formation of the solar system. And this process is called neutron star collisions, which builds gold by smashing protons and neutrons together into their atomic nuclei before throwing it out into space. And so in the early solar system, as Earth started to form, gold sank to Earth's core because it's very dense. Now therefore, gold in the crust near the surface is really hard to find. So all the gold found on Earth is actually formed from the debris of dead stars. And about 4 billion years ago, a bombardment of asteroids basically pushed some of the gold from the core into the mantle and crust. And subsequently, hydrothermal fluids, so this is hot water basically associated with rising magma, travels through the crust. And as it does this, it dissolves some of the gold in the crust. It picks it up, travels it towards the surface. When it finds fractures, so like cracks within the rock, it reprecipitates out the gold, forming these veins of gold, like veins in your arm. And that's how it looks on a rock surface. You have these sort of splayed out veins of gold and quartz and pyrite. And these normally form at 200 to 300 degrees C. And these form these primary deposits or epithermal gold deposits. Now, these can also be, because they're quite deep under the surface, they can be quite hard to excavate. But not to worry, there's also secondary gold deposits, and these are called placer gold deposits. And this is what we see when we see people sieving for gold. Now, the way this works is that erosion by water or ice frees up the gold from primary deposits. So the ice or water will scrape away at the rock below, the bedrock. It will pick up this gold and travel it downstream. Now, because gold's denser, it will sink to the bottom and accumulate in stream beds. That's how you can see how sieving works, because of the density variations. Gold's denser, therefore it separates from the rest of the lighter particles.
Have you ever panned for gold?
I haven't. Well, I assume you have then.
Well, I went to Legoland when I was younger, off the back of those vouchers you get on cereal packets. And I think at Legoland you can pan for gold, but I imagine it's not real gold.
It's not legitimate gold. Are they little bricks of gold coloured Lego? Is that what it is?
That would be nice. Maybe that's what it was. I'm not sure I can remember.
I should say that one of the largest gold deposits in the world in South Africa is the Witwatersrand.
How
You
do you
laugh
say
at
that?
that pronunciation. Witwatersrand gold deposit in South Africa. It's the
Hmm.
biggest gold field in the world. 40,000 tons have already been extracted. And it's composed of primary, so these veins, and secondary deposits, so the stream bed deposits. And hydrothermal fluids, so the veins, make up about 25% of the gold there, but 75% are in the form of these nuggets, which is the secondary, so like erosion, weathering
Hmm.
related gold. And this mining occurs up to 4 kilometers into the ground. So this
That's
is a
crazy
pretty
deep.
hefty. Can you imagine 4 kilometers into the ground?
Yeah.
So that was a nice little nugget. Thank you. All right. So that's how it forms.
But
Yeah,
we are
sorry. Yeah.
talking about when it was discovered and the fact that it's been mined for a long time. And gold, we think, was discovered thousands of years ago, but we're not quite sure when the first nugget was discovered. And flakes of gold have been found in caves used by Paleolithic man from as long ago as about 40,000 years. So it's been kind of on the block for quite a while. And the ancient Egyptians used it all the way back to Queen Zer, who was around in 3000 BC. Now, Tutankhamun, the very famous Egyptian pharaoh who was around in 1300 BC, so about 3000 years ago, had a gold coffin. And this is one of the largest collections of gold and jewelry in the world. I don't know if you've kind of seen any of this stuff. I have a feeling it might have used to been in the British Museum, or it might still be there. I'm not quite sure. It might have gone back to Egypt, but it's such an ornate kind of object. So clearly they were managing to find quite a lot of gold at the time. And they actually produced the first maps of gold mines, the Egyptians did. But interestingly, they never used gold as a bartering tool. So they mostly were using crops like barley as a form of currency. But the gold they kind of reserved for jewelry. But it did start getting used as money in 700 BC by the Lydian merchants. So I think there was a town in West Turkey called Lydia, and they were the first people to produce gold coins. And then it's had a very rich history. Get it? Thank you, thank you.
Yeah, yeah.
And then we had the gold rushes of the 19th and the 20th century, kind of the wild west of America, kind of going looking for gold. And one of the most famous of these was the Porcupine Gold Rush in the 1940s and 50s. So this was they were mining the Canadian Shield. So a shield is basically an exposure of basement rocks. So really, really, really old rocks, very stable rocks. And therefore it's quite rich in these kind of mineral deposits of things like gold. The rocks are between 2.5 and about 4.2 billion years old. They're called Precambrian or Archean, so they're very old rocks, and they have gold as well as silver, copper, and nickel. So kind of a good place to mine, and hence the gold rush.
Yeah. Yeah, obviously we've had various gold rushes, and I'd say gold's been used in by the very wealthy for thousands of years then. But obviously there's been a lot of attempts to try and recreate gold. So the question is alchemy possible? And the pursuit of alchemy has led to a series of bans and breakdowns, I'd say, from the individuals. Henry IV, for example, banned alchemy in 1404, and it was a law called the Act Against Multiplication, which basically means you couldn't produce and multiply like precious metals. If someone found out how to make gold or silver, it would make the crown's currency basically useless. That's why they put ban
But it's
in.
weird. It's weird to ban something that doesn't exist. I mean, obviously they didn't know that it's not possible. But like,
Maybe they thought they were getting close. Maybe it's
yeah,
like the Blackadder, and it's just they were creating pure green. Have you seen Blackadder?
not that episode.
Like it. Even Isaac Newton tried alchemy, but he suffered a nervous breakdown in the pursuit, uh, which could be due to the fact that in his pursuit of alchemy, it led to a lot of mercury fumes,
Right.
which meant that the mercury itself could have led to his mental instability.
Yeah,
Just
because it's kind of toxic, isn't it?
and yet we still have like tin fish all the time, which has got mercury in it.
Does it?
Yeah,
That's
well,
a
I mean,
huge bombshell to drop.
it depends where you shop. But according to a article I read, not even a scientific study, an article, the amount of mercury in some of these tin fish is outrageous.
Were the
And if you
publishers of this article, did the name start with Daily? Oh gosh.
anyway, uh, so Isaac Newton, one of the greatest minds, couldn't do it. So the question is it theoretically possible?
Hmm.
And everyone's pursued it from a chemistry point of view, but not from a nuclear physics point of view. So theoretically, it might be possible using nuclear physics. So elements are defined by neutrons and protons, which is basically the nucleus in the atom. And so chemical processes won't be able to transform one element to another. But what you can do is smash a nuclei of different elements together. And these particles are accelerated to high enough speeds in an electrical or magnetic field to smash and destabilize the nuclei of elements. In this case, it is possible to knock a few of the protons in a lead atom to produce gold. And this process is called transmutation. And it was done in 1980 by Glenn Seaborg, not on a scale, that's able to transform our gold production or gold markets because it's so expensive and the energy required is extraordinary. But it is theoretically possible from a nuclear physics point of view.
I think there's an element named Seaborgium or something like that. I imagine he was probably involved with that,
Really?
or maybe it was named after him.
Possibly, maybe it's it's lead, but it wasn't really lead. It was like bismuth or something like that.
Right.
That was the original. So maybe it's to do with some residue that's left over. I don't know.
Oh yeah, Seaborgium, atomic number 106, symbol SG, right down on the bottom of the periodic table.
What is it?
That's just an element.
Okay.
I don't know what else to say about it.
So, but from alchemy, from these pursuits, from a chemistry point of view anyway, has come other discoveries. So a guy called Hennig Brand in the 17th century, he was a scientist. He used all his wealth and with his first wife tried to find the philosopher's stone, which not
Little did he know that it's in Harry Potter's pocket.
yeah, it's inspiration for the elixir of life. It's a mythical substance capable of turning base metals into gold or silver.
Okay.
But it didn't go so well, and his first wife got pissed off that he was spending all the money. So he got a second wife, and his first wife left him. He married again, and he persuaded her, honestly, I'm so close to getting some gold. He's like, really? He's like, yeah, honestly, just give me a few extra dollars. And she helped fund his passion and his big idea. I don't know how he got the investment from his wife for this, but his big idea was to produce silver using urine. So not gold, but
adds
silver.
Up to me.
And he boiled down 5,000 liters of urine, which left a residue.
Yeah.
Which got added to a furnace, which a liquid started pouring out, and the associated fumes were luminescent. So he discovered phosphorus.
Oh, fair.
You know when like a fisherman comes home from work and his hands stink of fish?
Yeah.
A baker smells of dough. Do you reckon his stank of piss?
It can't have been a nice. I imagine these kind of gentlemen chemists or natural scientists of the day probably had their labs in their kitchens. Very,
or his bathroom.
Very patient of his wife. But what I enjoy in that story is the prominence of these wealthy women of the day who were keen to fund scientific endeavors.
Yeah, I mean, I don't know. He said he was a scientist, so his credentials are pretty good. But
checks out.
If someone came to me and said, "Look, I'm going to produce gold using my piss," I'm like, "No,
marry me."
So that's alchemy in a nutshell.
I had a quick question. So you're talking about being able to produce gold from these kind of particle accelerators, basically, right?
Yeah, like a hadron collider.
Yeah. So you know how, like, in technology, things over time get smaller and better. So, like, we have more power in our phones than the computers that sent the Apollo missions to the moon. So do you think one day you could have like a hadron collider in your home, like a desktop hadron collider?
This is like an interview question for university. It's like lateral thinking, isn't it?
Yeah.
Well, I think it's that big because it needs to get up to speeds high enough for it to cause these nuclei to explode and be disturbed. You know, the Hadron Collider is that big, I assume, because you have to get to 99.999, something like 99s,
Yeah.
the speed of light.
Yeah.
Hence why it's so big. So I don't think it's theoretically possible to get it as big as. I mean, you might have if you're Bill Gates and you have a mansion, that's a house
That's the size of a Hadron Collider.
Yeah, or a house that's the shape of a Hadron Collider, just a really thin, narrow house that's in a big circular shape.
Yeah. Okay.
A nightmare. You have to walk 12 miles to go to sleep. But I don't. I mean, I could be wrong. I could be wrong, but I can't imagine so. Which doesn't really lead us on to, but it's forcing a segue into what in the world.
Yeah.
So this week's what in the world, which we will finish the episode with, is about the Olympics. So I got a question, Marcus. What are the Olympic gold medals made of?
The fact that you're asking me makes me think it's not gold. Silver's made of silver, and is bronze made of copper or something? I don't know.
Yeah, you're right. So the question is then what? So it's not gold. So the question is, why do Olympic medalists bite, or gold medalists bite the medal? Obviously, gold, 24 karat gold, is the purest gold you can get. It's 99.9% gold. It's soft and malleable. So the best gold you can get is soft. And that's why people bite it, to check if gold is real. It could taste like carrot cake.
Yeah. Sorry.
So actually, what happens is gold medals at the Olympics are made of 92.5% silver, and it's plated with minor amounts of gold. The last gold medals to be served were in 1920 in Stockholm.
Really? For that long, they've not been doing.
Yeah, over 100 years. Yeah.
Apparently, there was a psychological study that found that athletes who won the bronze medal were significantly happier with their winning than those who won silver medals.
Because it could have been so much worse.
Yeah, well, I guess silver medals just missed out on gold, whereas bronze medalists were just happy to get something.
Ladies and gentlemen, that concludes our episode on gold. Thank you so much for listening. Our next episode is on ancient rocks. So how the Earth formed, the early atmosphere, and how many rocks over 4 billion years old are still on the planet today. In the meantime, stay golden.